Hey everyone. Today, we're going to pull back the curtain on a part of the internet that you use every single second you're online, but probably never think about. It's phone book. We're going to dig into how we're securing this absolutely critical system to build a much safer digital world for all of us.
But let me start by asking you a question. Just think about it for a second. When you're browsing the web, do you feel like what you're doing is actually private? Do you just assume that the sites you visit are your business and nobody else's?
Well, the hard reality is, it might not be. For decades, the very system that looks up every single website you visit, the internet's phone book, it's been operating completely in the open. And that, right there, is a massive vulnerability.
So let's dive into our first section and break down what this unseen vulnerability really is and why it's become so incredibly important to fix it right now.
Okay, so the system at the heart of all this is the DNS, the Domain Name System. Its job sounds simple, but it is absolutely essential. When you type a website, say example.com, into your browser, DNS is the magic that translates that into the numeric IP address that computers actually need to connect. Without DNS, we'd all be stuck trying to memorize these long strings of numbers just to check our email. No thanks.
Now here's the problem. Traditionally, that entire lookup process, it just happens in plain text. It's not encrypted. This means anyone from your internet provider to some attacker on the same coffee shop Wi-Fi can literally see every site you visit. This opens the door to huge risks, like someone eavesdropping on your browsing habits, or even worse, an attacker hijacking the process to send you to a fake, malicious website. And listen, this isn't just some theoretical what-if scenario. The scale of this problem is, well, it's staggering. We've seen a massive 876% increase in attacks that are specifically targeting this DNS layer. That makes this one of the most critical cybersecurity challenges we're facing today.
All right, so to really understand how we can fix this, we've got to peek behind the curtain and see how it works in the first place. Let's follow the journey your request takes every single time you click on a link or type in a web address.
It's kind of like a multi-step dance. First, your computer asks a local helper, which we call a recursive resolver, for the address. Now, if that resolver doesn't already have it cached, it goes on this little quest. It starts right at the top, asking the internet's root servers. They point it to the right top-level domain server. Think of that as the .com or the .org directory. That server then points it to the final authority, the specific name server for the website you're actually looking for, and only then does the correct IP address make its way all the way back to your device.
So, here's the absolute kicker. Every single step of that journey we just walked through, that whole conversation has traditionally been happening out in the open. It's like shouting your destination across a crowded room for everyone to hear. That is the fundamental flaw we need to fix.
Thankfully, some brilliant solutions are being rolled out. And the first fix isn't about hiding the conversation, it's about proving that the answer you get back is the real deal, that it hasn't been forged along the way. This solution is called DNS Seek, which stands for DNS Security Extensions. Basically, it works by adding a digital, cryptographic signature to all the DNS data. So when your device gets a response, it can check that signature to be 100% sure the IP address is legit, and that some attacker didn't mess with it to try and redirect you. A really good way to think of DNSSEC is like a digital notary. It creates this unbreakable chain of trust, all the way from the internet's root servers down to the final answer you get. It digitally stamps each step with a seal of authenticity, guaranteeing you are not being led astray. So how widely is this digital notary actually being used? Well, right now, the global validation rates are hovering around 35% or so. And while that is a fantastic start, it also shows us there's still a long way to go before the entire internet is protected from this kind of digital forgery. So, DNSSEC is amazing, and it solves the authenticity problem, but it doesn't solve the privacy problem. For that, we need a second fix. We need a cloak of privacy to hide the conversation itself. Let me put it another way. DNSSEC proves that the phone number in the phone book is the right one. That's absolutely crucial. But we still need to stop people from looking over your shoulder to see which name you're looking up in the first place, and that's where encryption comes in. And today, we've got a really powerful toolkit for this. The main protocols are DNS over TLS, or DOT, which is a solid backbone for encryption. Then you have DNS over HTTPS, or DO, which is really clever because it hides your DNS requests inside normal, everyday web traffic, which makes it super hard to block. And the newest player, DNS over QUIC, or DOQ, promises even faster and more resilient connections. Together, this toolkit gives us a strong shield for our online privacy. Okay, so let's bring this all together. What does all of this mean for you, for me, and for the future of the internet? Let's see where we're headed.
The really good news is that the tide is turning, and it's turning fast. Adoption of these security measures is accelerating. Major web browsers and even operating systems are now starting to enable encrypted DNS by default. This means your devices are getting smarter and safer, a lot of times without you even having to lift a finger.
Now, for those of you who want to be a little more proactive, here are the key things to do. First, make sure you're using encrypted DNS. Second, enable DNSSEC validation if you can. Third, think about using what's called a protective DNS service, which can automatically block malicious sites. And finally, just check your settings every now and then to make sure everything's still configured correctly.
You know, this quote just sums it all up perfectly. DNS is a foundational pillar of the internet. By evolving it with these new security extensions, we're reinforcing that very foundation against some of the most critical privacy and integrity risks in what is, let's face it, an increasingly hostile digital world.
So as we successfully start to lock down the internet's phone book, making it both authentic and private, we're kind of left with a final thought. We are making our digital foundation stronger every single day. So the question is, what's the next big frontier we need to secure?